This is Algebra 2 with trig. This is the worksheet A1 1A. First night's graphing homework. So we're going to look at this equation. We're going to identify the vertex of this absolute value. Remember, the vertex is always h comma k. So when we do that, we're going to be -2 comma -5. The h value of your vertex is always the opposite of what's inside the absolute value. Not because it's an absolute value, but because the original formula of the absolute value is -h. So it's the opposite of the h. So if this shows a plus, then the h had to be a minus, because two negatives, the negative h and the minus, is going to make it look like a +2. And then it's plus k, which means whatever the k value is here, -5, is going to be exactly the -5. In this case, the parent function is reflected over the x-axis and translated 2 units left, 5 units down. We knew that. We knew it was reflected over the x-axis because of the minus that's in front, and we knew it was translated 2 units to the left and 5 units down. Here, our vertex is going to be 4, 0, because there is no value for k. The parent function is stretched vertically by a scale factor. Let's get the word scale in there. By a scale factor of 5. And it is translated four units right. Because it's x minus 4, it's moved to the right. There is no up and down. Here we're going to write an equation of an absolute value that's translated 4 units up and is narrower than a parent. So it's going to move 8 units up. Try to make that look linear. Okay, and should be narrower than its parent. That means it's got to be a value greater than 1. It's not moved right or left, so we do not have an h, but it's moved 8 units up. This one is an absolute value. The vertex is in the second quadrant and is reflected over the x-axis. So if we're in the second quadrant, we're over here somewhere. It's got to come down negatively. So we could call it negative, because of course it's got to open downwards, because it's reflected over the x-axis. We have x. We got to move to the left, so it has to be a plus. We need some sort of numbers. You can call it 2 or 3 or 4, doesn't matter. And we're going to make it go up into the second quadrant. Call it 3, because it's got to be up. Go up any amount you want. So that would be a possible equation, but there's an infinite number of possible solutions. Here we're going to graph. We see that the vertex is going to be 5, 4. Now what we learned in terms of graphing these absolute values, we always start out, at least for this lesson, we start out with the parent function. And that's y equals absolute value of x. And then we're going to do the reflection, which is flipping it over the x-axis. Take all your y values and multiply them by a -1. So whatever we had before, we're now going to have the negative version of that. So we're going to have y equals negative absolute value of x. And then we take each one of our y values and we multiply it by 3. So it comes down 3 the first time. 2 times 3 is 6. 3 times 3 is 9. So it's still reflected over the x-axis, and now it's stretched. Sometimes your book likes to write that in one step, but I'm asking you to write it in those 2 different steps. Reflect it, then stretch it, then we're going to translate it, RST. So we're going to take each one of those dots, and we're going to move 5 to the right and 4 up. And that's the graph y equals -3 absolute value of x minus 5 plus 4. In our comparison, the parent graph is reflected over the x-axis, stretched vertically by a scale factor of 3 and translated five units right and 4 units up. You want to use these are math terms, like parent function, parent graph, reflected over the x-axis, reflected in the x-axis, stretched vertically or shrunk vertically by a scale factor, and then use the word translated. So for this one, we notice that the vertex is going to be at -2, -3. You can tell that right off the top. We also know that it's going to open up wider than usual, and it's going to open upwards. We'll start out with the parent function. And it's y equals the absolute value of x. And then the 0.25, which is a quarter. You could be a quarter here, and then you could be a half, and then you could be 3/4. And at 4, when you're 4 up, you're going to get pulled down to the 1. And at 8, you're going to get pulled down to the 2. So this graph is going to be y equals, there is no reflection, so we don't have to do a reflection. So we're doing a stretch now. You can say 0.25, or you can even say 1/4 absolute value of x. And then we're going to take that graph and we're going to move 2 to the left and 3 down. 2 to the left, 3 down. Take each point and move 2 to the left, 3 down. And that's going to be the graph y equals 1/4 x plus 2 minus 3. So we graphed our equation. The parent function is shrunk vertically. It's always vertically in the majority of our equations that we work with in Algebra 2 with trig. By a scale factor of 1/4 or 0.25. Translated, 2 units left and 3 units down. To the left, because remember it's always the opposite, and down 3. Start out with the parent function. So that's y equals the absolute value of x. There is no reflection, but there is a stretch. Now you might look at this and think it's a fraction, therefore it's a shrink, but this fraction is greater than 1. It's 2.5. So it's still vertically stretched. So every value is going to be multiplied. Every y value is going to be multiplied by 2.5. Instead of going up 1, we're going to go up 2.5. Instead of going up 2, we're going to go 2.5 times that, which is 5. And 7.5. 10. And we'd have the same idea over here. So that's going to be the graph y equals five halves absolute value of x. Then we're going to take every one of those values and drop it down 2. So we come down 2, come down 2, 2. Every one of those values gets dropped 2 from the red graph. So if it was in the middle, it goes to the middle. Let's be sure I'm lining those up correctly. And that's the equation y equals, or h of x, y equals 5 halves absolute value of x, which means it doesn't translate right or left at all, but it was translated down 2. The vertex was 0, -2, and the parent function is vertically stretched by a factor of 5 halves translated 2 units down. This guy is going to be at -6, 0. -6 because that's what's inside the absolute value. 0 because the k value is 0. We know there's a reflection. But we always start with our parent function. And that's y equals the absolute value of x. And then we know it gets reflected. And that graph is going to be y equals negative absolute value of x. And then we take that graph, and what do we do with it? Where does it go? Right, left, up, down? How far? Goes 6 units to the left. So you take every one of these dots and you're moving them over 6. Move every one of these dots over 6. Notice that there is no stretch or shrink to this one. So this is y equals negative absolute value of x plus 6. So the parent function is reflected over the x-axis and it's translated six units left. Nice job. Let's look at the flip side. This flip side has some algebra to be worked on. So we would distribute, and we could do this a couple different ways, but 2 times 6 is 12, so 12 thirds, and 2 times 9 is 18. So that gives me 4x minus 6 equals x plus 5 minus my x across plus my 6 across. We're left with 3x and 11. So when we divide, we get 11 over 3. So you're welcome to try a few of these, and then you can come back and run the video and see how it's working out. Don't just sit there and copy me if you think that you could actually solve some of this. If a problem gets tough, go ahead and try it yourself. What would you do if this was the final exam question? What would you do? And then you can come back and watch the video to verify what your actual procedure would have been. We get 16 minus 6q we add the 6q to the other side, add the 9, and we get 5. 5 goes into 25 5 times. 5 goes into 10 2 times. So 5 halves. That's the Q value. This one gets a lot of people. There's a couple different ways we could do it. Since the ends are like terms, we could get them to have common denominators, and since these constant numbers are the like terms, we could get them to have common denominators. You can even get all the numbers to be common denominators. But I'm going to look at the 9, the 2, 3, and 6. The common denominator, or what number they all go into, what's that? What number does all of these denominators go into? 18. So I'm actually going to multiply all of these numbers by 18. You could multiply 18 times 8, 18 times 1, 18 times negative 2, and 18 times 1. Totally works. But before I do that, I'm going to reduce with my denominator. So 3 goes into 18 6 times. 6 goes into 18 3 times. Now I'm going to multiply and get 16n minus. 9 times 1 is 9. 6 times 2 is negative 12 with the n. Plus 3. Add the 12n over. Add the 9 over. Divide by the 28. And we get 3/7. Here we're just plugging in our values that we know of. We have our exponents. We have to do them first. So we're going to square the negative 5 to get 25. A lot of people might make a mistake and multiply before you square. You have to square before you multiply in this format. Please excuse my dear Sally, PEMDAS. That tells us to do what's inside the parentheses first, and then exponents. So this is negative 75. This is 81. So we get the answer of 6. Plug the 3 in for the r. Do what's inside the absolute values. Not absolute values. Do what's inside the parentheses. Now, a common mistake, like I said, is people are going to call that 6 and 6 squared. But it's not. You have to do the exponents first, and then you can multiply. Remember PEMDAS? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division, addition and subtraction. Working left to right. Tells you the order for order of operations. So we're looking for like terms. We would have to distribute and distribute. So my x squares give me 1, and 12 gives me 13. My y's give me negative 3. And that's as simplified as I can get. I cannot combine the 13 and the 3. That's as close as I can get. Distribute. So my like terms, I like to do x's usually. So I see that we just have the 5x. My y's can come together. 10 and negative 9 just gives me a positive 1y. And then my 10 and 27 give me 37. Coming down to the last two, we're going to write the equation and identify some parts. So I notice it comes over 1, 2, and comes down 1. So negative 2, negative 1, that's my vertex. I see that it's going up 1 and over 2, up 1 and over 2. So it seems to have a slope of a half, up 1 and over 2. It's a V shape, so it's absolute value of x minus a negative, which shows it's a plus. And then minus 1 for a k value. So what's happening here is we are shrunk vertically by a scale factor of a half and translated. The parent function is shrunk vertically by a scale factor of a half. Translated, 2 units left, 1 unit down. Okay, for this next one, you go ahead and try to write the equation. The extra dot here is just showing you exactly where it crosses at. It follows the same slope. You write the equation and finish up and then turn it back on and watch me finish. So it looks like our vertex is over 4, up 3. I need to know where the vertex is at before I can write the equation. I see that it opens upward, so it's positive. I see the slope is 1, so I don't need to write a 1 unless I want to, so that's an absolute value bar. X minus 4, that makes it move to the right 4, plus 3 moves it up 3. Parent function is there's no reflection, there is no stretch. It's translated 4 units right and 3 units up. Nice job.